My name is Endre Sølvsberg and I'm a Brew 21 PhD candidate. This presentation is an excerpt of an article I wrote with my supervisory team for the 2023 APMS conference in Trondheim. The title is Identifying Customer Returns in PCB Production Using the Mahalanobis Distance. The use case is from the German automotive company Continental, specifically customer returns from a printed circuit board line in Sibiu, Romania. The units we have analyzed are PCBs for automotive cameras. We had access to both historical and current industrial data, and the main goal was to develop a multivariate statistical method to detect future customer returns as statistical anomalies, and evaluate the possibility for automating the method. Some challenges we faced during this work: we had access to data from inline testing stations, not direct production data. The data structure in Continental's data lake was quite complex, with each unique unit being represented by 20 to 30 columns and about 1,700 rows of data points. We had limited domain expertise, which was later changed when we included the chief on-site quality engineer in Romania. We had non-complete knowledge on what we call critical to quality variables and root causes, and there were issues with traceability throughout the production line, where the unit would change name in different stages of production. The method we ended up using for this case is called the Mahalanobis distance, and it is a unitless and scale-invariant multivariate method for outlier detection, which measures the distance from a point P to a distribution D in what we call an n-dimensional non-Euclidean space. This distance is calculated using this formula, which involves a covariance matrix, the inverse of that matrix, and some matrix and vector multiplication, ending up with the Mahalanobis distance. An interesting thing is that the square of this Mahalanobis distance closely approximates the chi-square distribution, which makes calculating critical limit for different confidence level quite trivial. It is also relatively fast, easy to use, and quite easy to understand for non-experts. The method was further automated using Python, and the code was tested using identity matrix testing and also using manual methods and some statistical software. We did some manual testing using a data pipeline from Germany to Norway and back, and after verifying that every step was working as intended, we placed the algorithm inside the so-called Docker container, which is a virtual container that is highly compatible with most industrial network environments. The container also included a graphical user interface, a search engine, and a reporting tool, and all of this was placed inside of the Continental network. Then some results. The method is able to detect about 20% of all future customer returns and has been implemented by Continental on-site in Sibiu. The non-specificity of the method means that, in principle, it can be used by all relevant production lines at Continental, and it also should be interesting for other industries and sectors as an effective tool for anomaly detection, and in addition, because of the relative ease of automation. Some future work is to perform the same or a similar analysis with an updated domain expertise, specifically pertaining to a higher percentage of known CTQ variables. We are also working on a paper connecting this method and other multivariate analysis method to digitalization and Industry 4.0 efforts and maintenance management to provide improved decision support towards ongoing lifetime extension efforts in the oil and gas sector.